Assalamualaikum warahmatullahi wabarakatuh. My name is AMIRRUL WAFIY bin RASHIDI from BMMV section 11. Today, me and my group will present the thermodynamics, which is BMMH2303, which is we're gonna take about the heat pump. Okay, first the introduction will be presented by me, AMIRRUL WAFIY bin RASHIDI. Okay, firstly, what is heat pump? Heat pump is a machine that generates heat transfer from cold to hot. For a heat pump, it is the ratio of heat transfer at the output, the hot reservoir, to the work supply for a refrigerator or air conditioner. It is also the ratio of heat transfer from the cold reservoir to the work supply. As you can see in the picture, there is a air conditioner which is located outside the building to cool the air in the building. Okay, how the heat pump works? The heat pump has four main components, which is evaporator, compressor, condenser, and expansion device. The detail about the evaporator, compressor, condenser, and expansion device will be explained by my group. Okay, the efficiency of the heat pump is denoted by its COP, coefficient of performance, defined as the ratio of total heat delivered by the heat pump to the amount of electricity to drive the heat pump. Okay, in the heat pump, it has two modes, which is cooling mode and heating mode. First, the cooling mode, the pump is moving heat away from your home, and for the heating mode, the pump extracts what outside heat is available and transfer it inside. Okay, the heat pump is use the first law, which is a version of the law of conservation of energy, adapted for thermodynamic process, distinguishing two kinds of transfer energy. Okay, what is the function of the heat pump? The heat pump cycle is fully reversible, and heat pump can provide year-round climate control for your home, heating in winter and cooling and dehumidifying in summer. Since the ground and air outside always contains some heat, a heat pump can supply heat to a house even on cold winter days. Okay, as you can see in the picture, heat transfer is constantly moving warm air from one place to another where it is needed or not needed. Heat energy is present when in air is too cold. Heat transfer heat inside when it's cold outside. It reverse direction and act like an air conditioner, removing heat from your house when it's warm outside. Okay, from the picture you can see the two situation, which is in the summer and in the winter. Okay, like in Malaysia we only have summer, so the heat pump function to cool the air inside the building. Like in Europe, they have summer and winter, which is in the summer the heat pump function to cool the air inside the building, and for the winter the heat pump function to heat the air inside the building. Okay, that's all from me.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is MOHAMAD Nazran HAKIMI bin SAHAR, and today I'm going to talk about mechanism 1 of heat pump. Okay, because my part is compression, so let's go. Okay, heat pump is consists of four pillars. Number 1 is evaporation, number 2 is compression, number 3 is condensation, number 4 is expansion. And for my part, I'm going to talk about evaporation and compression. Okay, let's go for second slides. Okay, I show you a video. Okay, the beginning of a cycle, the refrigerant is in a cold, low pressure liquid gaseous state, okay, flowing through tubes that are exposed to room air. Okay, the refrigerant is colder than the room air, so the heat in the room air move to the refrigerant because we want to increase the heat of the refrigerants. Okay, this is because heat is always find a way to move from the warmer things to the colder thing, because it's the nature, it's the law of thermodynamics. It's thermodynamics, because it was the heat itself want to do that. Okay. Many fans designed to increase the absorption of the heat from the warm air into the cool refrigerant, because the fans is the purpose of the fan on the video amplify the absorption by the increasing the flow of room air over the evaporator, so they will increase the refrigerant's temperature. Okay, this is the example of evaporator. So this consume of tubes. Okay, the refrigerant will move around the tube. Okay, and then the heat exchange occurs in the full system of heat exchanger. This is called heat exchanger. There's a lot of heat exchanger. There's oil heat exchanger, water heat exchanger, and that's a lot. Okay, so this one is maybe air heat exchanger. Okay, the evaporator is a low temperature heat exchanger where the refrigerants enter at a low temperature, absorb heat from the heat source by the evaporation at a low, and leave as a low temperature vapor. Okay, let's go for slide number 3. Okay, when the refrigerant leave the evaporator, they leave in as a warm gas at low pressure. We want a high temperature. We don't want warm gas. So there must come a compressor. As you can see, the compressor acts as to increase the temperature of the refrigerants. Okay, so the compressor produce a hot gas at high pressure. Okay, let's go for compression. Okay, this is the example of compressor. Okay, in the compressor, the low pressure of the low temperature refrigerant from the evaporator is raised to a pressure that is sufficiently high to match the desired condensing temperature in the condenser. During the compression, not only the pressure but also the temperature of the refrigerant will increase. Okay, the compressor just was to increase the temperature. Okay, that's all for my part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad FARHAN FIRDAUS bin EHYAK. Okay, I am going to explain another two mechanisms, which is condensation and expansion. Okay, condensation. The hot gas now give up its heat to colder water. As heat leaves the gas refrigerant, it cools off below its condensation point. So condensation happen at this point. This is exchanger. So the hot gas, the heat from the hot gas give up the heat to the water flow, So when the gas lost a lot of heat, it changed from a gaseous state to high pressure liquid state. So there is a large transfer of heat energy from the hot gas to the water. Okay, what is condenser? Condenser is a high temperature heat exchanger where the refrigerant enters as high temperature vapor, reject heat to the heat sink by condensation at high pressure, and leave as high temperature liquid. So as I mentioned earlier, basically the condenser change the gas state into the liquid state. Okay, this is the example of the real picture of the condenser. Okay, the last one is expansion. Now the cooler high pressure liquid refrigerant pass through the expansion valve. So as the liquid pass through the expansion valve, the pressure and the temperature are greatly reduced, and the liquid change into a vapor state, and then it goes back to the compressor. The refrigerant is once again ready to absorb the heat from the room air and repeat its cycle. Okay, what is expansion valve? Basically, expansion valve is one of the part at the heat pump that reduce the pressure and temperature of the liquid that came from the condenser. It also changed the liquid state to the gaseous state, and then sent back to the evaporator. Basically, there are three types of heat pump source. Number one, they commonly use the air source. And number two, the water source. Water source requires lake, well, or other source excess of water to use it. The next one is ground source or geothermal heat pump. It requires complicated installation and pricier, but at the same time, it quite efficient operation. Okay, these are the example of a source of heat pump. The first one is a vapor compression refrigerator. Okay, this, and the next one is a packaged air source heat pump unit. And then this is a boiler or tower heat pump, which is use water source, and then a geothermal heat pump system. Geothermal heat pump system using ground source.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Nazran bin Ahmad Khan. So today I will explain about the application of heat pump in industry, which is heat pump dryer. Okay, drying is an important industrial process. Various temperature levels and drying principles are applied in industrial dryers. The most common dryer type is one in which air is heated with steam, gas, or hot water and then circulated over the wet product. As the air picks up moisture from the wet product, its humidity increases and the energy contained in this steam may make it a useful heat source. Okay, so standard procedure is to exhaust this humid air or dehumidify it. With a heat pump, heat can be extracted from the humid air, and then the air is cooled down and dehumidified. The extracted heat can be increased in temperature and can be used to heat the dryer. Thus, the use of heat pump serves two purposes, which is heat the dryer and dehumidify and recirculate air. Heat pump assist drying can give the efficiencies because of this. Okay, this is conventional dryer without evaporator and condenser. Alright, the exhausted humid air contains a lot of energy. The temperature level of this air is low and direct reuse inside the dryer is therefore not possible. Application of a heat pump gives the possibility for waste heat recovery. With a heat pump, the extracted heat from the exhaust air is upgraded to a higher temperature level and reused to heat the dryer. Alright, first of all, we need to know that heat pump dryers operate with the use of two closed loop cycles. The first is closed loop air system, where the same air continuously cycles from warm to cool. The second one is refrigerant closed loop system, where refrigerant continuously cycles from warm to cool. The closed-loop refrigerant circuit functions similarly to that of an air conditioner. However, it removes moisture as well as warms the air to dry the laundry. Okay, based on this simple diagram, a drying process is shown that is heated with the use of a heat pump. As compared to the conventional dryer, in the heat pump dryer, the heat exchanger is replaced by the condenser, which is hot side of the heat pump. Furthermore, the air exhaust duct is connected to the air supply duct inside. Inside this connection, the evaporator, which is cold side of the heat pump, is installed. Hot air is circulated over a product belt inside the dryer. During the cycle, the temperature of the air will decrease as its humidity increases. About one-third the cool humid air is circulated over the evaporator. The evaporator cools the air further down below the condensation temperature. Below this temperature, the air will be dehumidified. The cool, dry air is then mixed with circulation air from the dryer. The mixture is heated to the desired process temperature inside the condenser and can be reused in the dryer cycle. There are 4 advantages of heat pump dryer. The first one is efficiency. The second one is heat pump dryer also more cheaper to run. And then heat pump drying also much gentler on clothes, and the last one is very important, is they are very convenient. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is AMIRRUDDIN ROSLAN. Today I want to explain about the conclusion of heat pumps. So the first point is what energy used in heat pumps. The heat pump use mechanical energy to transfer thermal energy from a source at a lower temperature to a sink at a higher temperature. So the electrically driven heat pump heating system have attracted wide interest as an alternative to electric resistance heating or expensive fuels. So the heat pumps may use air or water sources for energy, and dual source machines that can use either under development. So we go to the second point. So the second point is the application. The applications that can apply, one of them is a solar system. The Scottish Animal Health Planning System combine a solar heating system with a heat pump to provide the necessary heating and cooling requirements. Both air-to-air and water-to-air heat pumps can be used in this system. The solar system basically collects the energy for the heating requirements, and the heat pump supplies this energy at the proper time and temperature, and also helps to improve the efficiency of the solar collector in the water to air operating mode. So we go to the third point. The third point is advantage. Heat pump systems have other advantages for commercial buildings besides their low operating costs. They offer improved comfort due to on-demand, year-round heating or cooling. Greater flexibility in the interior layout of the building is also possible, particularly where a distributed water loop configuration is adopted. In addition, more exterior architectural freedom is possible with the adoption of geothermal heat pump systems due to absence of any need for external equipment such as cooling towers. Because of their use of electric power, heat pumps can also a convenient way in which to heat a building in a remote location to which fossil fuel is not economically transportable. So the last point in this conclusion, heat pump is capital intensive. Heat pumps are capital intensive as solar energy systems. Consideration of the economics of Scottish Animal Health Planning System indicates that it may be difficult to justify the investment in a heat pump to improve solar energy system performance unless the cost of the heat pumps can be justified on the basis of its use for air conditioning, or unless the use of the heat pump would reduce collector costs to a small fraction of their current levels. Today, the most popular commercial heat pump configuration in the United States, Japan, and the other country such as Turkey is the single package air source unit.